introduce yourselves, the combination you do, and we'll continue. Thank you. Let's start with Aaron.
Hello, good morning.
Please tell us. Yes, good morning.
Yeah.
Yes, good morning.
The combination what we do, we are two in class, and all of us we do geography, and agriculture stock some math.
Very good, thank you. The other?
Yeah.
Yes, William.
My name is Nakunda Sarah, and I also do gear.
My name is Nakubura Kakarin. I offer mayor.
Okay, thank you. Yes, we have Karim. Yes, please, Karim, introduce yourself. As is preparing, let us have Wanyama. Wanyama, please introduce yourself so that we save time. Yes, Karim, you are speaking, but we are not hearing you.
Yes, good morning. This is Karim.
Yes, please.
About agriculture.
Yes,
I
please.
am here attending with my students.
All right, thanks so much, Mr. Karim.
Yes.
Okay. Yes, let us have Wanyama introduce and tell us the combination. Wanyama, please. Yes, Pascal.
Yes, thank you, teacher.
Yes, please.
Can you hear me?
Oh, we are not getting you. We are not hearing you.
Also, I was requesting the students, in case they are not speaking, they could keep their microphones on mute so we can have some order, and also to turn off their videos.
Okay.
Also, I wanted to ask Mr. Karim, how many students is he attending with?
Yes, thank you so much. I'm attending with 10. Hello?
Okay,
Yes,
10
please.
students. Which school are you from, please, if you don't mind?
I am in Chaba Secondary School in Oyam District. At Chaba in Oyam District.
All right, thank you for joining and you're welcome. Teacher Omara, please continue.
All right, thanks so much. Thank you for your participation. I request the others use the videos that we have. If we have effective communication. William Prosper, may you please turn off your video so that you can start on. So this discussion we are going to have, I will request you to participate in a way that when I call upon you to do the reading of the question and then try to interpret, to give suggestions, I request your contribution per amount. as we all know that always in paper 2, there is section A, which has a compulsory number, which would be either a graph or a information in a table, which needs to do some bit of interpretation. And here we are. Is I request William Prosper to read for us. It's number 1. Thank you.
The following data gives the fresh and dry weight of a whole pea plants 8, 20, and 33 days after sowing in potting soil in normal light and in continuous darkness in a greenhouse. The weight of various parts of the seedlings are given in grams. FW for fresh weight, then DW for dry weight. Have the average weight of 50 seedlings in normal daylight, beginning from 8, 20, 33. Then average weight of seedlings in the dark, 8, 20, and 33. Then we've got shoots for fresh weight and dry weight. Then roots, fresh weight and dry weight. I think you can see the figures. Then cotyledons, fresh weight and dry weight. Then the whole plant, fresh weight and its dry weight.
All right, thank you so much. So I request each of us to be observant of these figures. For example, let's look at number 1, which is the shoot. The shoot we are able to see. Hope somebody can tell us which part of the shoot. What are the parts that compose the shoot? Hello, team. What are the parts that?
Stems,
Pardon?
stems,
Yes, sir.
flowers.
Okay, thank you. Please, maybe for us to be not having the echoes and then struggling to speak at the same time, you could raise up your hand and then we give you a chance to speak. Similar to Mr. Karim, in case one of your learners is interested. Similar to Mr. Karim, in case any of your learners is interested in participating, you just raise up your hand, then chance is given to that person to say what they want to say. Thank you for that. So somebody was telling us that the stems, leaves, and then the branches, those are the parts that make up the shoot system. Now, when you talk about the dry, who can define for us what fresh weight is? Yes, somebody tell us what is fresh weight?
Yeah.
Yes. Hello.
Yes, sir.
Yes, please. Define for us fresh weight.
Fresh weight.
Yes, please.
Yeah, fresh weight in terms of normal weight. That's what I know.
Okay.
That's all.
That is. Thank you.
Yes,
That's according to him. It says that is not weight. Any other definition besides that?
No, it is a weight of an organism with water content inclusive.
Okay, thank you very much. Thank you. He has said, maybe you could have told us your name so that we'll be able to refer. He says that it is the plant system which contains the water content in it. The tissues are all intact. There's chlorophyll, there is water, etc. So now, understanding what fresh weight is, let us define what is dry weight. Yeah, somebody define what dry weight is. Yes. But Tim, you are saying something?
Dry weight of a plant.
Yes, Prosper is putting up the hand. Yes, please.
Dry weight of a plant is that weight of the plant that has lost its moisture content.
Okay, thank you very much. She has defined that the dry weight is that amount of weight measured after removing the water content or the moisture content from the plant or the shoot system, the shoot alone. Okay, so now after understanding those two terminologies, we come into our table and we start to we come into our table and we try to understand and analyze. We try to analyze our table. For example, let's start by the first line here. Let's first start with the first column, which talks about the average weight of the 50 seedlings in normal daylight. Okay. And then the other side says average weight of seedlings in the dark. Okay. One of this is supposed to be the control experiment. We shall know afterwards as we continue. Then after that, here they've told us when they measure the fresh weight, they are able to they are doing the experiment in 33 days. The first day, 1 week, which was 8 days, and then they had the 20 days, and then 33 days. Of course, all of us know that 31 days make up a month. So when we have 8 days and 33, that's a total difference of different days. The other is a month, this is a week. So when they planted this seedling in the pot, the seedling of a pea, they planted it in the what? In the pot, it germinated. After germinating, they went and measured it. The first week, the first 8 days, they found out that the fresh weight was 0.4. When they continue to measure again the next after 2 weeks or after 20 days, they measured again, they found that it was 1.53. And when they measured, again they saw that the thing is increasing. It has now gone to 3.13. Okay. Similarly, they continued the other plant, which was also in the dark place, in the dark corner. There was no light. This one was in the light. The first measurement after 1 week it was 0.66. And then after 20 days, it was 1.42. Okay. I hope you're observing the figures. Is there any decrease or increase? Hello? Hello? Yes, William Prosper. Your hand is up.
I think there is an increase in the average weight from the 80th day to the 20th day to the 30th to 33 days, because we see it started from 0.4 to 1.53, then to 3.13. Then for the average weight of the seedling in the dark, it also increased from 0.66 to 1.42, then to 2.67.
Okay. Thank you very much. That was for the case of the shoot. That was for the case of the shoot. So let us look at can somebody describe for us, analyze for us the shoot for the dry weight? What happened in the plant, the seedlings which are planted in the normal day, what happened in the first week, which was 8 days, and then the second 20 days, what happened? Somebody tell us. Yes. Come on, 11, please. Can you rename your device such that we'll be able to know the personnel having the phone? Yes, please. Any person, Mr. Karim, anybody in your class who wants to describe for us the dry weights of the shoot system? Hello. William Prosper, please. Can your colleague also describe for us the next?
Yeah, for the average weight of 50 seedlings in a normal daylight, for the dry weight, it increased from 0.04 to 0.12, then to 0.26. Then in the average weight of the seedlings in the dark, it also increased from 0.04 to 0.07. Then from 20 days to 33 days, the average weight of the seedlings was constant.
Okay, thank you. Any other person to describe for us the roots, the fresh weight and dry weight of the roots? Anybody in Mr. Karim's class to tell us? Hello. Hello. Okay. Now, in the second experiment where they had the roots, they went and measured the roots. They measured the fresh weight of the roots, and the first 8 days, they were able to measure the fresh weight and it went to 0.35. As they measured on after 20 days, they found out that it increased from 0.35 to 0.55. Afterwards, after 30 days or 33 days, it increased to 0.97. Okay. Whereas the other plant which was planted and kept inside a dark room, the seedlings, when they measured the roots, the fresh weight of the roots, at first after 8 days it was only 0.31. Hope you are seeing the variance. At first, for the fresh weight, it is 0.35, but here, while in the dark, it was 0.31. After 20 days, okay, after 20 days, they measured and they found that it was 0.39. When they measured after 33 days, it again dropped, okay, from 0.39 to 0.35. Okay, that was for the part of the fresh weight. Let's look at the dry weight. After drying off, they got the roots, they subjected them to high temperatures, it dried. When they went to the lab to measure, they found out that the dry weight of the roots in the first 8 days was 0.02. After 20 days, it increased to 0.04. And then afterwards, it went to 0.01. When you go to the other side of the other plants which were planted in the darkness, you'll find out that the first 8 days, it measured 0.20, and then it went to 0.002, and then 0.002, meaning it became constant. Let's look at the cotyledons. the cotyledons. Yes, Aaron, may you please describe for us the cotyledons, the fresh weight of the cotyledons and the dry weight of the cotyledons in both plants? Hello, Aaron, the floor is yours. Yes, Aaron, please talk to us. The mic is yours. Oh, William Prosper, if you are set, you can.
The fresh weight of the cotyledons is decreasing from 0.71 to 0.47 to 0.4. Then the average weight of the seedling in the dark is also decreasing from 0.71 to 0.47 to 0.4.
Okay. Let your colleague lead us also in the dry weight.
The average weight of 50 seedlings in a normal daylight decreased from 0.13 to 0.03, then to 0.01. Then the average weight of the seedlings in the dark, it also decreased from 0.13 to 0.03, and then to 0.01.
Okay, thank you. Thank you. So maybe before we continue, we are busy discussing the shoot, the root, but what are the cotyledons? Somebody define us what a cotyledon is. Yeah, somebody. Okay, so here, a cotyledon simply means the first leaves, the initial leaves that germinate, okay, that come out of the seedling. For example, if it is a bean seed and is growing, the first leaves to appear, okay? Because, you know, cotyledon are those parts of the seedlings which have the, which always turn green when the seed germinates. So that's what we refer to as the cotyledon. When measured in the first 1 week, which was 80 days, it was the fresh weight was 0.7, just like as our colleague has described. So the whole plant now, let us look at the whole plant. We have the shoot, we have the roots, we have the cotyledons. Somebody describe for us the whole plant, the fresh weight of the whole plant. Aaron or team, please take us through. Yes. Prosper, are you willing to take us through the whole plant? Describe for us the whole plant.
The average weight of 50 seedlings in the normal daylight for the whole plant, it increased from 1.45 to 2.85. Then it increased to 4.51. Then the average weight of the seedlings in the dark, they decreased from 4.64 to 2.40. Then from the 20 days to 33 days, it increased to 3.51.
Okay, thank you very much. After us analyzing and understanding what the table talks about, we have understood at least the fresh weight, we have understood the meaning of the shoot, the cotyledon, whole plant, etc. Let us look at the first questions that we have. Our question number 1 for number 1A is compare the changes in the dry weight and fresh weight of the whole plants grown in the normal light. Okay, hope you are noting down the question. Have you put down the question in your summary book? Hello?
Yes,
Hope
we
you
are online.
Okay.
Yeah, we are noting.
Great. So now, who is willing to answer for us the first question? Compare the changes in the dry weight and fresh weights of the whole plant grown in the normal light. Okay. Let us first go back to the graph and we see. Let's go back to the graph. Okay, here's our graph. Describe, compare the changes for here, for only this last.
What range is it?
For only this last. Hello? Somebody describe for us this last, the whole plant. Compare the changes. What changed? Was there any change between the days? Hello, anybody willing to describe for us and give us a comparison? Yes, Prosper.
As the fresh weight of the whole plant increased rapidly, the increase in the volume, the average weight of the seedling in the normal of the whole plant in the dry weight increased gradually. Then in the average weight of seedlings in the dark, for the fresh weight it increased rapidly, and for the dry weight it increased gradually.
Okay, so all in all, we are seeing increase in both the fresh weight and then the dry weight. As simple as that, and we have already finished to compare the changes in the fresh weight and the dry weight of the whole plant in the normal light. With B, who can read for us? B, Aaron, read for us the question number B, letter B. Aaron, please. Yes. Yeah. Yes, Karim.
But these days, compared
Yes, please, Karim, continue. Please, we are hearing you. Okay. Oh, we are not getting you. Maybe you could read for us and we continue.
It says, but these days, compare the changes in soil and of this grown in normal daylight and darkness.
Okay, thank you very much. Although you have not told us your name, thank you very much. So it says that part B says compare the changes in dry weight and fresh weight of the shoots grown in daylight and darkness. So we have two comparisons. We are looking at, first of all, number one is the fresh weight and the dry weight of the shoot. Okay. In a normal daylight and then the darkness. So let's go back and look at our graph. Here we have the shoot. Okay, the shoot and the the fresh weight of the shoot and dry weight of the shoot, both in seedlings, the ones which were planted during the presence of light, then those that were planted in the darkness. Okay, somebody take us through. Who can answer for us that question? Anybody who has an idea? Hello? Anybody with the idea? Yes, please. Prosper and your colleague, and Aaron or team, please. Discuss for us the changes that occurred. Yeah, we are not hearing you, Prosper.
The average weight of the seedlings in the normal daylight, both for the fresh weight and the dry weight of the shoots, increased rapidly from 0.4 to 1.53 to 3.1. That was for the fresh weight, and then the dry weight also increased rapidly from 0.04 to 0.12, then to 0.26. Then for the average weight of the seedlings in the dark, also increased rapidly from 0.66 to 1.42, then to 2.67. Then for the dry weight, also increased rapidly from 0.04 to 0.07, and it later became constant from the 28th day to 33 days with 0.07 and 0.07.
All right, thank you. So let us first look at our question once more. That's how we have been able to compare the changes. There were changes. On the other side of the plants that were grown in the presence of light, the dry weight and then the fresh weight was increasing. But when it came to this side of this, when we're measuring the fresh weight and dry weight of these plants which are found inside the dark room, the fresh weight and dry weight was decreasing. At the point it reached even whereby the dry weight became constant. The dry weight became constant at 0.007. Okay. So now let us have our C. Somebody read for us C.
Question B says, that's the changes in the materials current type of embryo and plant. I guess the explanation for the changes. And then
Okay, thank you. it says that the question states that discuss the changes in the distribution of materials between the different parts of the embryo and a plant. Okay, and suggest explanations for the mentioned changes. Why is it that when we measure the dry weight of these seedlings at the 8 days, there was an increase or a decrease? What causes that? Okay, that is the explanation that we are looking for when it comes to this question. Someone who can help us answer section part C. Oh. Yes, Prosper, tell us.
You first bring back the graph.
Here is the graph, please. Yes, please. Could somebody describe for us why there is such a distribution in the embryo and the plant, and what are the causes of that? Yes, Prosper. Anybody in Karim's class? Yes, please. Please. Don't just keep quiet. I feel like it could be the answer.
Can you please add an answer? Maybe first take it back.
Pardon?
I'm saying you first tell us back, then you take it back to the question. Where the question is.
Okay. We put it back to the question. And then
The fresh weight of the embryo is decreasing.
please continue.
May you return the table?
Yes, please. The table is here. What causes the decrease and then the distribution? Yes, members, please. Where?
I can't see the table.
You can't see the.
I can't see the
Sure.
table. The table.
Okay, let me reshare my screen once more. Are you able to see this table now?
No.
Maybe your gadget could be having a challenge.
I can now see it.
Okay, that's great. Please peruse through and give us a suggestion.
The fresh weight of the cotyledons decreased from 0.71 to 0.47, then to 0.40. Yes, and the one for the whole plant was increasing from 1.45 to 2.85, then to 4.51. And it is because the cotyledons are manufacturing food for the whole plant, and therefore they lose their weight and the plant gains the weight.
Okay, thank you for that answer. Thank you for that analysis. Okay, any other member who can back up on her point? Hello, members, let's be at par. Anybody in Karim's class, then or somebody, I see somebody call it Techno, come on 11, please rename your device and then you contribute. Okay, it seems that's where the only answer for now. So what happens here is that the distribution of these materials between different parts of the embryo and plant is different in a way. The shoot system, let's look at it. This table. The shoot system has increasing, measure this one in the light. It has increasing fresh weight because more leaves are being developed. Because when the leaves are there, it means that photosynthesis occurs due to the presence of chlorophyll. So when these leaves are very many, continuous reproduction of many leaves, that the shoot has increasing fresh weight and then increasing dry weight. Because once dry this many leaves or other shoot parts such as the stems, the branches, they will be having an increasing number of the dry weight. So that is one. Similarly, let's look at the fresh weight. All of us know that some of these roots have other roles such as storage. Okay, they store the starch in them. So as they store this starch in them, they act as a storage area where we have water, we have starch, and so many more. This one is also increase the weight. That's why you see it constant, increasing from 0.5 and 0.35 to 0.55 continuously. The same matter. As we have the starch inside there, this starch also has potential to increase the size of the dry matter. Once we remove the starch and water, the content which remains, the biomass it increases while decreasing. That's why you find that. That's why you find that at first we have in the 0.00. After 30 days, we have the 0.01. It decreased. It increases at the initial first stages and then it decreases. So that is the explanation that we expected or we could have. So that is the explanation that we expected for that. Of the last question, which says, explain the conditions that influence citron. Okay, who can give us some? This one at least everybody should give an answer. They want 4, but please let us give as many as possible. Conditions that influence this seed germination. Conditions that lead to seed germination, please. Members, contribute. This one is a very simple question. If you give it to a P1 chap, P3, that's even answer while their eyes are closed. Yes, so Moding, Christopher, you're welcome. Yes, Prosper, you're saying something?
One is oxygen, which is used for respiration.
Yes, please.
Point number 1 is oxygen.
Yes.
And oxygen is used for respiration.
Very good, very good, very good. And then other points? Your colleague should give us also some points.
Another point is water, which hydrolyzes starch that provides the.
Okay, very good. Yes, other members like Omoding, like Tekino, come on 11, please tell us. Tell us, because these points are 4. We have mentioned oxygen, we have mentioned water. We also need light, okay? For germination to take place, there should be light. Maybe somebody could tell us what is the light during germination? Importance of light during germination. Light facilitates photosynthesis. Okay, it helps to degenerate. It helps to degenerate the nutrients. The nutrients which are to break down the nutrients which are found in the plants, in the seeds, such that the seedling germinates flowers. Okay. All right. The last point, please. The last answer. Tell us, members. Members, let's be interactive. Let us be interactive. Yes, Hakim, you're welcome. You performed us discussing the part 1 of number 1, which says explain the conditions that influence seed germination. And colleagues have mentioned that water is a necessity for germination to occur. And then they said also that oxygen is paramount for seed germination. They also mentioned that light or sunshine is also wonderful for germination to occur. What other point have they missed out?
Another point is warmth, which activates the enzymes.
Okay. Now, when we talk about warmth, yes, when we mention about the sunlight or the sunshine, the sun, it means that the sun will provide the warmth. Okay. So in your explanation is where you bring in how the sun is able to provide the warmth which leads to degeneration of the stored food, and later it will lead to the growth of the seedling. Thank you very much for that beautiful answer. The last point, please. It's only 1 point lacking. Yes. Please, members, share. Members, please share with us. Yes. Okay, so we have talked about oxygen, we have talked about light, we have talked about warmth, which is temperature, and then other factors. We have dormancy. Okay. We have dormancy. If the seed is facing dormancy, there's no way it can germinate. So we need first to break the seed dormancy. Okay, so that also has potential to stop germination. Okay, let us go to section B. I finished section A. Now we are having section B. Somebody read for us the first, the number 2, A and B. Read for us, please.
What are the characteristics of suitable soil for plant growth? Then part B, explain how cultural measures can be used in soil and water conservation.
Okay.
Part A, number 2, part A. What are the characteristics of suitable soil for plant growth? Then part B, explain how cultural measures can be used in soil and water conservation.
Okay, thank you. Yes, members, let us give contributions. What are the characteristics of a soil for plant growth? Before you think of growing a crop, okay, think about the best soil. What are the characteristics that you need in the soil? Okay, members, let us be participating. Hakim, please tell us. Hakim. Come on, 11. You contribute and we move faster.
I was saying that I'll join later because I've just started, so I need to set a little. But anyway, I'll join along the way as we continue participating. Thank you.
All right, thank you so much for that. Yes, Prosper, please. You and your colleague, you could be able to give us some suggestions. Hello? Hello? Could tell us. Okay, factor number 1.
The suitable soil for plant growth has dark color for temperature regulation.
Very good. Dark color.
The soil should be well aerated.
Well aerated. Excellent. Any other? You could also say that the
Okay. Hello.
Yes, please. We are getting you.
Yeah, I think this question requires us to discuss the qualities of a good soil. Of course, the qualities of a fertile soil, those are the very factors that will really contribute to the suitability of the plant growth. For example, soil depth. The soil has to be with a required amount of soil so that it can hold the plant roots and so the plant roots are able to penetrate through to suck the mineral nutrients. Then it has to be well aerated, that has been talked about. It should be well drained. Then should have a required amount of nutrients in the soil. Then it should have living organic matter. Then should also have the organic matter in place. That is my contribution on that. Thank you.
Thank you so much, Akim. Thank you very much for those points. Akim said the depth of the soil should be deep enough to enable the roots to anchor into the soil properly. Then he has said the soil should be nutritious, should be having all the nutrients such as the calcium, nitrogen, the phosphorus, the nutrients should be present. And he also said the soil should have the living organisms, because these living organisms help to aerate the soil, and they also help the soil improve the fertility of the soil. If they die, they decompose and accumulate newer. Very good. And then he said organic matter is a key. Okay. Organic matter, sometimes it is referred to as organic matter, or it is referred to as humus. These ones are very good for improving the soil. Thank you so much, Karim, Hakim. So, dear members, we have been able to list down.
Welcome.
List down six. We're remaining more 5, even above 5. There's no problem. Yes, please, Prosper, as if you are saying something.
The suitable soil for plant growth should be free from pathogens.
Yes, should be free from pathogens. These pathogens can easily cause diseases. And when we say should be free from diseases, the soil-borne diseases. Yes. Any other?
Should have a good water holding capacity.
Very good. Water holding capacity should be. I think that works better. Should be well drained. Should not hold water for a long period of time, because that is bad. It can lead to rotting of our root. And should again leave water to move through it very fast, because that also causes lack. of water for our crops. So it should be well trained. Thank you. At least let us raise more two. More two. So more two. The soil should be free from pests. Okay. That can also be another point of its own. Hello, any other points? One extra. I'll go to the next point, the next question. Okay. The next says, explain how culture measures can be used in the soil and water conservation. Water conservation, okay, culture measures, these are measures which are used to control, to conserve water in the soil without using chemicals, without destroying the soil. But how can you use these methods to maintain the water in the soil? Okay. The culture we have forestation. Growing of trees, we have agroforestry. Okay, those are some of the culture measures we have. Okay, so now, how can we use those methods to maintain soil and water in the soil? Yes, Prosper. Hello.
Mulching the soil to prevent soil erosion.
Yes, please. Prosper, saying something.
I said mulching the soil to prevent soil erosion, and also remember, if you mulch maybe your soil, the water will instead just enter into the soil and will not even wash away the soil. Hence,
Okay.
conserving water and soil.
Very good. The other point also is crop protection. First of all, crop protection is one of the current measures to control conservation. So crop rotation, when you change various crops, different crops on the same piece of land, you control erosion of the soil. For example, this time around, you plant crops such as the crops apples, the pumpkins. These ones grow on low on the ground, so they don't wash away the soil. Then grow the peanuts, nuts, beans. These ones they don't allow we grow away our crops. So they don't need sunlight or sunshine to keep the soil. Once temperature is it's going to evaporate, and once it evaporates, it leads to loss of water from our those are some of the two methods. Any other method? For example, another method we have the contour farming. In case you are in a hilly area, okay, you grow the crops in contour way around, okay, around the hill. This also helps to control erosion. At the end of the day, the water is conserved and the soil is also conserved. Another method you hear and how it helps us is planting of trees. Agroforestry, plant trees and the crops together. At the end of the day, you'll find that the trees act as windbreaks, which stops our soil from being blown away and also avoids loss of water from the soil. Okay. Any other contribution? Thank you very much, Karim. You are back. We have found us discussing number 2B, how cultural methods or measures can be used in soil and water conservation. And we have listed some of the cultural methods such as the agroforestry, crop rotation, mulching, etc., and so many more. How are these methods useful in water and soil conservation? Thank you. The floor is yours still. Hello. Hakim, please. Any other contribution on this number? Hello, members. Any other contribution?
Start the video. Good recording.
Yes, we are here. Come on, 11.
Application of organic manures.
Okay, very good. Explain to us how it conserves the soil.
Explain. Like when we apply the organic manures,
Yes.
here the soil will receive the natural fertility.
Okay, thank you. So when you apply the organic manure, the soil is able to bind together because there is a binding effect. The soil is put together to formulate a soil structure which is not broken away. In the long run, the water and soil is conserved. Thank you very much. Any other point?
Another point is planting of cover crops.
Very good. Explain to us.
When you plant the cover crops, it reduces on the water runoff, and then soil is conserved because it's not taken away by the fast running water.
Wonderful. Thank you very much. Such a brilliant point. Any other points?
Terracing.
Yes, please.
Terracing also reduces the speed at which the water runs off, therefore preventing soil erosion and conserving water within the soil.
Okay, very good. Thank you so much for exhausting those points to the maximum. So let's have number three. Number three. Somebody read for us number 3, A, B, and C. Read for us number 3, A, B, and C.
What are the reasons for encouraging agroforestry in Uganda? Then Roman B, mention the characteristics of a good agroforestry tree species. Then suggest the measures that have been taken to control destruction of forests in Uganda.
Thank you very much. Thank you very much for reading for us. So members, maybe who can define for us what agroforestry is? Before we go into the reasons why agroforestry is encouraged, let us understand what is agroforestry. Yes. Oh, we are not hearing you. We are not getting you. Somebody in Karim's class.
Hello, I'm
Yes.
I'm aware of this. Yes, this is the growing of trees and crops in the same piece of land.
Okay, thank you very much. She says that agroforestry is the growing of crops and trees on the same piece of land. Is there any other divergent definition apart from that?
Agroforestry is a farming system which involves the growing of crops, trees, pastures, and rearing of animals on the same unit of land.
Excellent, very good. All those are very good points, but I want us to take this point. This is a farming system, okay, which involves the growing of trees and crops on the same piece of land. Okay, thank you very much. All of you are very brilliant students. This is very nice of you. Okay, so let us give the points, reasons why agroforestry is encouraged in Uganda.
Trees.
Yes, please.
Trees are sources of food to animals.
Very good. There are some trees which act as pasture to the animals. Any other point?
Yeah, support to climbing plants.
Trees help in breaking wind. They are wind barriers.
Yes, the trees act as windbreaks. In the case the wind is too much, the trees act as the shock absorbers. They reduce the strength of the wind. Okay, thank you.
Roots of the trees control soil erosion.
Okay. He says the leaves of the trees control soil erosion. They control wind erosion. Okay.
Right.
But again, there's another fertile point there. You could say that the leaves of the trees fall on the ground, decay, and add into the soil, hence boosting soil fertility. Okay, you have to give points like an A leveler who is willing to go to campus. Don't just give a point which has no flesh. You just mention and you don't back it up. It will not be good. Okay, you need to give a point and then you explain. Okay, thank you. Any other point?
Yes, offer
Trees. We obtain timber from trees, which is used in construction of farm structures like a crush.
Very good, very good. The point is very clear. We get timber for construction of farm structures. Any other point?
The tall tree is like trees encourage the growth of small trees like the coffee to encourage coffee growing.
You have not been clear. Please, may you repeat yourself?
I was saying.
Yes, please.
Hello?
Yes, please.
My name is okay. I'm saying it also encourages the growth of other trees like
okay.
For example,
encourages. Oh, it's okay.
The growth of other small.
Okay. He says that agroforestry leads to diversification of farm activities. And he gave an example of carving coffee, okay, and then other crops. Thank you very much. So let us look at B. Mention the characteristics, okay? Mention the characteristics of a good agroforestry tree species, a very good one, okay? Members, please let us give characteristics of a very good agroforestry tree species.
It should be compatible with other tree species and crops.
Pardon?
I said it should be compatible with other tree species and crops.
Yes, it should be able to coexist with other tree species and the grass. There's one which you plant and then the next morning you'll find that the whole garden is dry. All the crops have dried up because it has high consumption of water and nutrients. And even it covers the plants and prevents them from getting enough light. Thank you very much. Any other characteristic of a very good tree species?
Hello?
Yes, please.
It should have this purpose to absorb water from the soil and grow.
Okay. Any other?
Should be able to grow in various soil types, for example, in fertile and fertile soil.
Yes, should have potential to adopt any type of soil. Yeah. That's great. At least more 3 good characteristics of a tree species.
It should have deep roots to absorb water for the plant growth.
All right, very good. Yes, Prosper, are you saying something? Yes, there are our colleagues who are requesting for the first table. You'll get the first table. This information will be given to you in the WhatsApp group. Don't worry. Yes, please.
It should be able to resist harsh climatic conditions such as strong sunshine.
Okay. should be able to withstand harsh weather conditions such as too much sunshine, which sometimes drought, etc. Thank you. Those are all very brilliant points. And then here we have the last question, which says, suggest the measures that have been taken into control to be taken to control destruction of forests in Uganda. What have you people in your community done to control destruction of forests? What has the government done to control destruction of forests? And what do you suggest should be done? Okay. Yes, please. Let's embrace the question.
The government has set strict rules or strict laws against forest destruction in Uganda.
Okay, the government has put up some laws which are against deforestation. Very good. Any other?
By sensitizing to people the dangers of destroying the forests.
Very good. There have come different organizations and governments to teach people, to sensitize them on the challenges of destroying all trees. Thank you very much. Any other?
The next point is diversification of other sources of power like electricity and solar.
Please, your network is unstable. We have not heard you properly.
Okay.
Yes.
Okay.
Encouraging afforestation and reforestation.
Encouraging afforestation and afforestation. Very good. Any other point?
Also, electricity and solar panels.
My friends, I'm not hearing you properly.
Electricity and solar.
Sorry for that. Your network is breaking. Yes, please, colleagues, let's continue and give more suggestions. At least 2 more, and we go to the next section.
Use of biogas limit.
Adopting use of biogas and hydroelectricity power to avoid the use of firewood as fuel.
Okay, very good. Thank you very much. Thank you very much. All those are very brilliant ideas. So, when you find such a question, when they say suggest, doesn't need you to overwrite very many things. You write the background, you write what? No. When they say mention, you just have to do what? To mention at least a sentence. Okay. But when they tell you to explain, explain means first give the point, after giving the point, and then you back up the point. That is so you back up the point. When you back up the point, that point has flesh and is able to earn you enough marks. Let us go to the next section. Section C. Colleagues, could you read through the first question, number 4? Read through number 4.
Section 4 is outline the importance of water in the body of an animal.
Okay. B. Yes, somebody take us through B.
Question B says, explain the factor influencing the amount of water intake in the animal.
Oh, okay, thank you. So A says, outline the importance of water in the body of the animal, of an animal. When such a question comes, even you are an animal, you start you start now comparing yourself. Why do you take water? Okay, because these are the same points. Let us start giving answers for A. How can we answer A?
Genetic work.
Yes.
My name is it provide a medium for biochemical reaction in the body of the animal, like example, enzymatic work.
Yes, very good. It provides for bioreaction of chemicals in the body of the animal. Thank you. Yes, any other point?
Water is used to regulate the body temperature.
Very good. Water in the animal's body is important in regulating the temperature of the animal, because all of us know that high temperatures can lead to death. For example, the pigs, in case there's no water, the animal can die. And also for proper production of milk. So water has to be there. Yes, please. Any other contributions?
Fertilization.
Pardon?
I said it aids fertilization by spinning gametes.
Okay, it aids in fertilization.
Water.
Yes. William Prosper is telling us something. Importance of water in the animal's body.
Water is a universal solvent which dissolves all materials in the animal's body for easy transportation.
Okay. It enables transportation of the animal's body. Any other?
Water helps in the release of waste products from the animal's body, for example, through urea through urine.
Water enables us to expel materials in our bodies, such as urea, and it comes out of the body through urine. Any other? Yes, please. Okay. Okay, let us look at B. What are the factors that influence the amount of water intake in the animal's body? What are the ways which make animals to take more water? Yes, please.
High temperatures.
Yes, when temperatures are very high, the animals take a lot of water such that they cool their bodies.
The water. Saline water encourages small intake.
Okay, please members, any more?
The healthy status of the animal. That's to say, healthy animals take in large amounts of water as compared to the sick animals.
The next is the size of the animal. This the animal is taking more water than this. Example is cows and the goats.
Any other? Even the nature of food. If it is a dry food, it requires the animals to take more water, for example, the hay. But if it is eating succulent food, it does not need a lot of water. Any other point?
This is an activity of the animal. For example, like taking cows, taking more water.
Okay. Any other points?
The breed of the animal. For example, the exotic breeds take in large amounts of water compared to the indigenous ones.
Okay. Here we are looking at this. One of the colleagues said the health status of the animal, whereby the person said when the animal is sick, it takes more or less water, but when the animal is okay, it takes much water. But the animal is okay. Animal is okay. But even the animal, it is a normal breed. Let's say animal is okay. Animal is. What are the factors which will make the animal to take more water? That's why I find that those points on breed and point of the health status of the animal, because we are looking at why will it take more water? Okay. For let's see that point of the animal health may qualify because influence means either minimal or influencing the amount of water taken in. Sometimes it's less, sometimes it's more. So when it is cold, it means that the animal will take less water. But when temperatures are high, it will take more water. So that point of breed, please, it be one of the last points after putting up serious points before. Okay. Thank you. Let's continue with our discussion. Aiko, Andrew, please share with us what you can. Aiko, Andrew, Prosper. We have just given only something like 5 points. I need to be expected to give 7 serious points, 7 to 8, such that the explanation answers 2 marks.
The age of the animal.
Okay, explain to us.
All the animals taking less amounts of water as compared to all the animals taking large amounts of water as compared to the young animals.
Okay. Okay, here let me ask a question. Between the heifer, okay, the juvenile animal, and then the old animal, which one is more active? Which one is more active? Between the old animal and then the juvenile animal, or the heifer, the one which has not yet given birth, and the one which is old has given birth, and the rest, which one is more active?
That young one which has not yet given birth.
So that simply means that we would have stated that the age of the animal, this young one has many activities. It has to produce blood, it runs on heat, it eats too much. So that one takes more water compared to the old one. So our point was supposed to be the age of animal. Okay. Thank you. Any other point?
The work of the animal, for example, the drought animals take in much water due to their heavy work during plowing.
Very good. The purpose of the animal. Yes. There is so as the gas means in water in that they do too much work. They need more water to replace during the exercise of plow. So our should always be the parts of the animal. More as we continue. Number 5. Yes, I call your hand is up. Talk to us.
Yes, I will suggest that the type of feed taken by the animal also determines the amount of water taken by such animal.
How much take to ensure the production of good. Hello? Hello, members. Well, due to our interest of time, we are going to be tackling one number. We have finished one number in section C. Let us go to the other section. Let us go to section D. Our last section. Hello. So let us look at one number here, and then we conclude. Number 6, describe the qualities of a good feeding trough. Good feed trough. Hello? I call Prosper, please. Hello, members. Our time is fast spent. I expect you to be active such that we conclude in good terms. Yes, I call your hand is up, please.
Yes, one of the qualities of a good feed trough is that it should be clean.
Yes.
Should be clean.
Should not be
It should be leak-proofed.
Yes, it should not leak at any point, should be clean always to avoid diseases. Yes, please continue.
Should be large. It should be large.
Yes, it should be large enough to enable the animals to eat from it. For example, the chicks, the chicken, and then even the cattle. If it is for a cattle, they should be able to feed comfortably. Okay. Even the height should be of optimum height, the one whereby the animals can access so easily. You cannot get a very tall feed trough which is taller than the chicken which is supposed to feed from it. It will not be good. The chicken will not enjoy. Okay, so B, explain the factors that influence the size of the feed troughs. What do you use to determine the size of the feed troughs?
Type of the animal, poultry that is to use it.
Okay, very good. Type of the animal. Yes, your hand is up. Talk to us.
Yes. In fact, the size of the animal will determine now the size of the feed trough. So the feed trough should always be at a reasonable size where the animal can comfortably take in water or take in feed. Thank you.
Okay, thank you very much. The size of the animal. Any other point?
Another one is the number of the animal, where very many animals require large feed trough.
Okay, the number of the animals also influences the size of the trough. If there are very many animals, you will put a very big trough. Okay, any other? Yes, colleagues, may we continue? Okay, meanwhile, since our time is fast spent, I will love us to first move through section in agriculture economics. We have two questions here. There's one which says, discuss the measures that could be taken by Uganda government to stabilize market prices of agricultural products. And that is the current situation we are facing today. We would love you to advise government what can it do. And then B, what problems would be encountered in implementing the measures you have discussed in A above. Number 9 says, what are the causes of increase in demand of agricultural commodities currently in Uganda? Why is demand so high for agricultural commodities? And then, how does price fluctuation of agricultural products affect farmers? Okay, let's now do number 8 and we conclude for today. Let us discuss number 8. How can the government, what measures can government put in place to stabilize agricultural prices? Yes. Yes, I got talk to us.
Yes, government can subsidize the agricultural inputs. This is where government will reduce on the cost, in fact, reduce on the tax on these inputs so that the farmers can get them at the lower price. And this also will determine the amount of, this will now determine the price of the agricultural products. Thank you.
All right, thank you very much. He says that the government should reduce taxes on agricultural products such that they are easily accessible, they become cheaper. That's one measure of stabilizing agricultural prices. Any other point?
Offering agricultural credit to farmers.
Pardon?
Offering agricultural credit to farmers.
Yes. The government should offer agricultural credit or loans to farmers such that they are able to increase production. When production is high, it means that the demand is stabilized. Okay. When the demand is stabilized, it means that the prices of commodities will not rise. Rise in price simply means that and the commodities in the market are few. Okay. So that is enough. Thank you very much. Any other point?
Establishing buffer stocks in case of excess.
Yes, continue. We'd love to hear that explanation.
Like when the supply is so high, there should be some buffer stocks like that. They store that excess, then they leave that adequate supply, such that prices can rise again.
Okay, very good. They should put storage facilities whereby the farmers store their goods in case they have produced in excess, such that they can sell when there is less in the market. Thank you very much. Any other point? Let us look at the B. What are the problems encountered in implementing the measures you have discussed above?
Corruption and embezzlement of funds. This is a situation where the corrupt official misappropriate funds that was supposed to be directed to the farmers.
Okay. Any other challenge or problem faced by government in implementing the discussed measures above? Hello. Okay, colleagues, it seems we have come to this place. Somebody is mentioning something.
Yes.
Yes, please continue.
The illiteracy of the farmers, like they are unaware of how to control excess production.
Okay.
Then another point is the seasonal production of agricultural commodities.
Yes, please.
Like if now the season is for harvesting season, it leads to excess production of those agricultural commodities, which increases the prices, lowers the prices.
Lowers the prices.
Yes.
Okay.
Then Another point
So, yes.
I have is the perishability of the agricultural commodities, such as vegetables like tomatoes.
Excuse me. Here, the question we are answering, okay, is how the government stabilizes. The factors you are giving, those are factors which lead to price fluctuation, okay? The increase, the perishability, increase in supply, in production, okay? Those are factors which lead to price fluctuation. The changes in prices. For example, if you talk about excess production, if production is too much, the prices will fall because there is too much in the market. So, but here we'll discuss the measures that can be taken by Uganda government to stabilize prices, to make sure that we avoid the increase and decrease of prices. Okay, so that's what we are looking at. I don't want us to misfire this point, this question. Hello? Hello?
Hello?
Okay, our time is fast spent. Yes, please. Yes, Aiko, we are waiting to hear from you.
Yes, Chiomara, thank you. And thank you everyone who has attended. Once again, my name is Pasco. I'm from Yaka Digital Network. We have come to the end of our seminar for agriculture. And we are having more and more of these sessions every Saturday, depending on which subject you're taking. And we also have online classes in case you're interested. I'm going to put my number, our number in the chat. So in case you need online facilitation, in case you need any notes, we have them all together. Let me put our number notes in the chat. So this is the contact for Yaka Digital Network. In case you, let me send it everyone. In case you're interested in online learning, notes and everything to do with digital learning, contact us so we can be of help. So otherwise, thanks for attending. Okay.
Okay, this is where we have stopped for today. See you next time.